Hi, this is the third video of educational series of videos on LoRa chipset. Today I'm going to discuss about the fundamental low-level programming for SX1262 LoRa chipset with STM32 microcontroller. To do a LoRa project and to make the learning easier, of course, we need a LoRa shield and a development board like Nucleus board. Today I'm pleased to introduce a new tiny LoRa development board. It is a combination of Ambient LoRa shield and Nucleus L47XRG board with a tiny dimension. It's a 4-layer PCB with signal, ground, power, and signal stack up to improve the board signal integrity. The board is equipped with an ultra-low power ARM Cortex-M4 microcontroller from ST Microelectronics, SX1262 LoRa Transceiver from Simtech Corporation, BME280 sensor, which is an environmental sensor with temperature, barometric pressure, and humidity from Bosch. Serial wire debug or SWB protocol to program and debug the ARM microcontroller. USB to serial interface, which allows the user to send the output of the serial port in the USB port. USB-C connector to power on and communication with the development board through either the laptop or PC. Tactile switch as the board preset switch. 2 LEDs to display the status of the busy and the interrupt of the digital I/O1 pins. LED for troubleshooting of the MCU program. It has 2 pin headers on both sides of the board that allows the user to access to the MCU GPIO pins. The picture shows the pin out of the development board. As can be seen, the LoRa chipset is connected to SPI1 and BME280 sensor is connected to I2C1 and UART1 is used for board debugging. The first step is to know about MCU GPIO configuration in terms of input, output, and interrupt. We need 5 GPIOs and 1 SPI peripheral to communicate with LoRa chipset. The first GPIO is NSS, which is active low slave select pin. The second GPIO is NReset, that is going to use as a reset signal. It's an active low pin. The third GPIO is ANTSW, which is an antenna switch to control CTR pin of a RF switch. The fourth GPIO is busy, that is used to indicate the status of the internal state machine. If the busy line is low, it indicates that the internal state machine is in the idle mode and the radio is ready to accept a command from the host controller. The fifth pin is DIO1, that is a generic interrupt request. Any interrupt can be mapped to DIO1. The interrupt will happen when a package of the data receive or transmit. The DIO1 pin will change to the rising edge. First of all, let's open the CubeMX to create a new project. Click on the New Project tab and search for the microcontroller. In this project, we are going to use STM32L476 RGT microcontroller. In the RC tab, we wouldn't use external crystal, so that we skip this tab. In the System tab, we select serial wire as a debug method. In the Connectivity section, click on the SPI1, select Full Duplex Master as a SPI mode. In the parameter setting, data size must be 8-bit, first bit is a master, and baud rate is 62.5 kilobit per second, just for the test purpose. However, SX1262 is allowed for high-speed communication up to 16 MHz. So let's do MCU pin configuration, which I already explained. The first GPIO is PA0, which is going to use for a slave selection. So we select the pin as an output. To make the program readable, let's assign a user label name to this pin. The second pin is PA4, which is going to use for LoRa chipset reset pin. So we select the pin as an output. The third pin is PA1, that is the busy pin and indicates the LoRa chipset state machine. So we configure the pin as an input. The fourth pin is PC4, that is going to use as a control pin of RF switch, and we are going to configure as an output. And the last pin is PC2. We configure the pin as an external interrupt pin and we enable pull down internal resistor. GPIO mode must be configured rising edge trigger to make sure we would receive interrupt during the data exchange. Make sure in the NVIC tab external interrupt checkbox is ticked, otherwise we wouldn't receive any interrupt. As I mentioned earlier, the development board is going to use USART1 as a debugging port. Let's enable the port. Select the project name, we click on the generate code. Thank you for watching. I hope you found it helpful, and if you did, make sure to give it a thumbs up and subscribe to my channel if you haven't already.